So after some research, we found out about Druid. At a high level, Druid is a very fast, highly scalable columnar data store. And now we'll see what it really means. Just before we dive deeper into the details of Druid, I wanted to show you that companies with all shapes and sizes are currently using Druid in production. So Airbnb and eBay, Nielsen Marketing Cloud, obviously, AppsFlyer, the Israeli company that initially helped us with Druid, and of course, Imply. And why is Druid cool? So first of all, it can store trillions of events and petabytes of data, which is what you want when you handle big data. It can serve analytic queries in sub-second. It's highly scalable and cost-effective. And it has a decoupled architecture. So for example, the ingestion process is separated from the query process, which is, it kind of answers the problem we had with Elasticsearch. So the other thing you need to know about Druid is that it's a time series database, which means it partitions its data first and foremost by some kind of a timestamp column, like this timestamp column in this example. Other types of columns are dimension columns, which are basically string attributes you can filter your data by, like this attribute column here. And metric columns, where you aggregate your data by and perform calculations on, like this device ID column right here. All those types of columns comprise of what is called in Druid a data source, which is basically an equivalent to a table in a relational database. So now that we know that Druid is a time series database, we also want to share with you that Druid has a very powerful feature that's called rollup. So we are talking about analytic queries. So we are not really interested in all the raw data, right? Like this raw data in this example in the upper part of the screen, this table. But actually, we want the aggregated result of a query, like this table in the bottom part of the screen. So what Druid does on ingestion time, it aggregates the data based on the dimensions that you defined, and basically stores only the relevant count or the relevant metrics that you wanted to produce. So in our example, you can see that for a specific timestamp, for a given attribute, say 111, let's say it's an impression, right? Some kind of an advertisement for a campaign. 3 devices were exposed to this campaign. So in this case, we aggregate the data and count the number of devices, and we will just store 3 as the number of devices that were exposed to the campaign, or actually the number of impressions, as we say in AdTech. Now, this provides us with the ability to actually get a much more compacted result. And then in query time, what Druid needs to do is more similar to a key value store, where it only needs to retrieve the relevant row or rows that are relevant for our query. So this is an example for the simple count, but we are talking about the count distinct. So the count distinct is somewhat similar. You can see we have the same raw data, but now we actually want to store the unique devices that, for example, were exposed to a specific campaign or a specific advertisement. So you can see in the raw data, we have the same device ID twice, and we have another device ID. So what we actually want to do is store the number 2 as the number of unique devices that were exposed to this campaign. Now, this is somewhat simplified because actually Druid doesn't store, when you do a count distinct, actually Druid doesn't store the number 2. And the reason is, as Yakir mentioned earlier, we want to do various operations between various attributes. So we want to know the number of unique devices used by female in US that are interested in tech, for example. So we cannot just store the number 2 for attributes, say female. What Druid actually stores is some kind of a Theta sketch object, a memory structure, a data structure within the memory. And then on query time, what it does, it can perform unions and intersections between those Theta sketch objects. So this is basically using the Theta sketch aggregator, gives us the ability to do all those set-theoretic operations we want to do on our 80K plus attributes. So if we look at how our data flows in production into Druid, so as Yakir mentioned, we have a large Kafka cluster that holds the raw data. From there, we have Spark applications that read the data and produce Parquet files on S3 with those tuples, so a timestamp, an attribute, a region, which in our example is the country, and the device ID. Those Parquet files are being loaded into Druid or basically aggregated using built-in MapReduce job that Druid provides. And then we can aggregate them using the SUM aggregator or the Theta sketch aggregator and produce the aggregated data to the deep storage, which is S3 in our example. And from there, as I mentioned, Druid loads the data, or actually the historical nodes load the data into the disk and memory, and they can serve queries to our SaaS application.